Yeah, so this talk is about some commonalities that I've seen through some big incidents, which I will talk through in the first half of the talk. One at Google, another at Stitch Fix, and another at WeWork. And then the second half of the talk will be about, well, what can we take away in terms of lessons, for less about managing incidents themselves, but more about what we do post-incident and how do we change the culture and change the behavior and maybe even change the organization to make sure that we don't have big outages going forward. So super briefly, my background is in the last 15 years or so, I've been at all of these companies. So I was chief engineer at eBay for a while. I spent some time at Google as director of engineering for Google App Engine. So that's where that story is going to come from. I was VP of engineering at Stitch Fix for 2 years, and that's where I will tell that story from. And then currently for the last almost year, I've been VP of engineering at WeWork. So let's start with the Google App Engine outage. So this is back in October 2012. This is a little bit of an eye chart, but I will talk you through it and highlight some interesting things. So broadly what happened is App Engine was down globally for 8 hours. So that was not a great day for the App Engine development team nor for the SRE team. What happened? At the beginning of that 8 hours, we got increased load in one of our data centers. The SREs, which were super wonderful, I loved working with all of them, did their standard playbook, which was globally restart the router layer that we had in App Engine. For this particular load-related failure, this playbook that had worked for a long time didn't work, and so we ended up experiencing a cascading failure where we lost data center 1, then data center 2, then data center 3, all the way around globally. And so ultimately, after trying lots of different other schemes, the SRE team decided that we needed to globally restart, and then half an hour later, everybody was up. So this wasn't great. Snapchat, which was a thing then, even then, Snapchat was down. The predecessor to Pokemon Go called Ingress was down. Lots of the 3 million applications that run on App Engine, including lots of internal Google services, were down as well. So we wrote up a public postmortem, which these are referenced from. So I'm not showing you anything internally to Google. So we did two things. In the immediate term, we increased the capacity to those routers so we wouldn't experience that particular class of failure. But more importantly, and more the theme of the rest of the talk, is that we spun up multiple projects, which I'll actually call a program, around what are fundamental changes that we would need to make to how we operated in order to reduce the probability of this happening in the future. So I'm going to talk in detail about the post-incident. We called it reliability Fixit at App Engine in order to fix a bunch of these issues. And I'm going to take you through step by step, and you're going to see that I have executed this same playbook at the subsequent places. So the first thing that we needed to do, so we did our standard postmortem. So we wrote up exactly what happened, what went right, what went wrong. But this was a big deal. This was the biggest outage that to date App Engine had ever had. So this was like another class of problem. So what we did is we got everybody in a room, all the leads, all the product managers, a bunch of stakeholders from sister teams that were involved with us, and we basically went and met in a big room with a whiteboard. Because this was a big reliability-related issue, and it had happened because of an accumulation of small decisions that we'd made over a bunch of years, we basically wanted to enumerate all the things that we knew about and all the things that we suspected might be issues going forward. What we realized immediately was that we had accumulated a lot of technical debt, which we'll talk about how we fixed going forward. We had not been prioritizing reliability issues in the way that clearly we maybe should have. But the most interesting output of that problem, or of that problem definition or identification phase, was that we bucketed the kind of brainstorming into 8 or 10 themes. And so what we did was we then had somebody volunteer to be the person that would sort of take forward that theme. And what we did is we time-boxed their work for the next week. So we said, a week from today, we're all going to come back in this same room. you 8 or 10 people that are managing the 8 or 10 different themes, you're going to come back with a set of suggested projects or suggested things that we should do after some research, and then we'll all talk together about what things we should do now, what things we should do later, et cetera. We just have a prioritization idea. But the key thing was to get it all out in the open. And the other thing that I think worked, well, one thing that worked really well was the time boxing, right? Not kind of making the prioritization immediately, but also not waiting a month or a year to collect all the stuff that we needed to do. And then the other thing that I thought worked really well with this was that we had people come back with just, the project was essentially one line item and do an order of magnitude estimate of how difficult you think this is going to be. Is this like 1 day worth of work? Is this 1 week worth of the work? 1 month, 1 quarter, 1 year kind of thing? Does it make sense? Like a super simple, we need to fix X, Y, Z, something that was actionable, but there's no design doc, we do that later. Just enough for us to be able to understand the cost of this thing, the potential benefits, and then so that we could prioritize. Cool. So step 3 was, again, that week later, we brought everybody back together again. Again, all the stakeholders, both product and engineering. We discussed all those themes, and we prioritized the work. And the work that we didn't prioritize in the near term sort of went on a backlog for something that we might consider doing later. And then we were ready to start assigning engineers to get working on fleshing out those individual projects that we identified and getting going. So within a week, we were able to spin up this big program that actually ended up for a while taking maybe a third or a half of the team for a short period of time. And so the step 4 was that implementation phase. So we had people going on for the next months, working on those assigned tasks that we'd identified. And from a tracking perspective as an engineering leader, again, we did something really simple where we just had a spreadsheet where each row represented one of those little projects or those little tasks. And we just updated the status weekly, and in our global all hands for App Engine once a week, we would just update where we were with the reliability stuff. So super lightweight from a project management perspective for the engineers, and also super lightweight for the pointy-haired manager, which was me. So that worked out great. The results were pretty great. So over the next year, we had a 10x reduction in the reliability issues that we were having in App Engine. The thing that maybe I hoped for, but I couldn't have really counted on, was by prioritizing these kind of technical debt-related work, it improved the team cohesion and camaraderie a lot. Like it really brought everybody together around this common cause, and it gave engineers both pride in the reliability of the system, but also some trust that we're going to continue prioritizing these kind of engineering or reliability related stuff. Does it make sense what I'm saying? Cool. And this is wonderful. I feel very happy about this. This is a big effort on lots of people's parts. But when I get together with I don't work at Google anymore, like I say, but when I get together with the friends of mine that I work with then, we all still remember, hey, remember that reliability Fixit? Wasn't that awesome? Anyway, and so again, it had great benefits both in terms of the reliability of the system, but also the cohesion of the team. Great. So a similar story in concept, different in detail at Stitch Fix. So Stitch Fix is a clothing retailer, uses a ton of data science and machine learning to figure out what kinds of clothes people will like, and then sends those clothes through the mail. This was a list of a bunch of the outages, again a bit of an eye chart, in October and November of 2006 when I was there. The only thing that's really relevant in this is that all that red. So of the outages that we had in various systems for these 6 weeks or 8 weeks, more than half of them related to the shared database. And as soon as you hear me say the shared database, you know already that there's a problem. And so that was the main thing that we needed to solve. So again, we execute. I'll tell you a little about the problems, and then I'll tell you about the playbook that we executed. So we identified that because we had a shared database that was all the common entities of Stitch Fix, lots of different applications all needed to be using stuff that was in there, so they were contending on the common tables, as you'd imagine. Also, the scalability of the overall system was limited by the number of connections we could make to that database. And then the implication, the obvious implication, but to say out loud to other people in product in the business, is that any one application could essentially take down the entire company. So that wasn't great. So we did a similar playbook to what we executed at App Engine. So we had got everybody together, we identified the problem, we understood the problem, bucketed those things into themes, some of which I shared with you. We did some consensus and prioritization to figure out what was near-term most important and what things we needed to spin up for later. And then we started implementing and following up. And again, we got great results. So I'm happy to share that there still is a shared database, but lots of services have been extracted from that shared database in the interim time, and we did a lot of work to make sure that the shared database wasn't under as much pressure as it had been before. So how did we do that? We focused on reducing, first logging, and then eliminating, and then rewriting the expensive queries that were increasing the load on the shared database. We needed to manage the database connections as a scarce resource, so we used a connection concentrator for that. And then we spun up a long-term, what we called stability and scalability program, where we would make an ongoing, in this case, 25% of engineering effort investment in migrating services out of the shared database and improving reliability. Does that make sense? Cool. All right. WeWork. Again, similar philosophy, different in detail. So in the last couple of months, members of WeWork, so WeWork is a co-working company. We're headquartered actually here in New York. We have buildings and therefore members all over the world, every continent essentially except Antarctica. And we had a bunch of members that weren't able to log into our systems. We diagnosed the problem. We figure out that that was a result of different services. We have microservices architecture, not a single shared database or a single application, but those different services and applications at any given moment might have different views of what a user was allowed to do, and when those things were inconsistent, sometimes that would mean that a user wasn't able to log in or do the work that they needed to do. So those inconsistent representations were one of the fundamental problems. And over time, system interactions that had started out very simple had, as you might imagine, become more complex and more convoluted and more involved. And from the sort of client side, we didn't have kind of graceful degradation or what I'll call automated repair in place to kind of notice when different systems in our different backend systems weren't agreeing and repair it more automatically. Anyway, so these were a bunch of the issues. Again, we executed very much this similar playbook. So we got everybody together, we identified the problem, we tried to bucket those things into themes like I suggested, we brought everybody back together to prioritize that work in a consensus way, and we are now in the process of implementation and follow-up. So I look forward next time we talk to have the step 5 results, but we're in the middle of this right now, so I'm confident we'll get there. Cool. So what are some common elements? This looks like a bit of a pattern, and I'll say openly, like this was a pattern that just seemed to work well in App Engine, and it seems to have worked well at other places, so that's why I wanted to share it. So I'll talk a bit about some of the common elements to extract, and then I'll be more specific in the second half of the talk about some lessons that we can all take away. So the first common element, and it's obvious, but let's say it out loud, is the kind of technical debt element, where unintentionally, over the long term, all of these places had accumulated sort of the results of small, like individually reasonable decisions. Like these were all decisions that well-meaning people made reasonably along the way, but in the aggregate, those things accumulated to threats to the overall reliability of the system. In all of these cases, it took what some of the safety literature calls a compelling event, i.e. an outage globally, right? It took something like that to catalyze long-term change. And if I could make a little sidebar here, the sin is not that you have an outage. The sin is that if you don't take the outage and make it better. Does it make sense? The sin is not something bad happened. The sin is not making the thing better subsequently to that. Cool. And then the other common element in all these places is that a blameless culture, so a culture of blameless post-mortems and a culture of being very transparent and open in those retrospectives, made it possible to learn and improve over time. So it made it possible for us to do that Fixit program in Google App Engine. It made it possible for us to do the stability and scalability program at Stitch Fix, and it makes it possible for us to execute the program that we're executing now at WeWork. And then, as I mentioned, applying this same kind of post-incident pattern, this sort of structured approach, seems to have been really helpful. And then the other common element, as I was trying to hint in my sidebar a moment ago, is we shouldn't feel, when we are in a hypergrowth mode, we shouldn't feel weird or surprised that the system has issues. And in fact, if we had built the system from the very beginning to never have had any issues, we probably would have spent all of our time doing that and none of our time building products that people would actually use. Does it make sense what I'm saying? The way that I like to say it is, if you don't end up regretting your early technology decisions, you probably over-engineered. Cool. Okay, so let's talk about some of those lessons, right? So first set of lessons is going to be around leadership and collaboration. The second set of lessons will be around quality and discipline. And the final set of lessons will be about suggestions that I've had for being successful at driving these long-term changes in engineering organizations. So let's start with leadership and collaboration. The first thing, as you saw evidenced in all of these examples, was doing blameless post-mortems. So it's so important, as we've all said many times in this and other conferences, to be able to have an open and honest discussion about an incident that happens. We want to ask ourselves, how could we have detected this earlier? How could we have diagnosed this more quickly? How could we have mitigated this more easily? How could we have remediated it more quickly? And how maybe could we have prevented it going forward? And if we do this in a safe space, I know that all of you that have done this will know, but if we do this in a safe space, it's almost like engineers are going to compete to take personal responsibility. So in the App Engine outage, there were a bunch of teams that had contributed to it. And once we got going, it would be like, oh, you think you guys were bad, like we weren't even taking backups and the replication wasn't working, and it's almost this weird competition. And that might be surprising if you're not an engineer. Most of us are. But this is the place that in the engineer heart where that comes from, right? It comes from, finally, we can prioritize fixing that system that I've been saying was broken for so long. Does that sound familiar to anybody here? Yeah. Laughter and lots of hand raises. Yeah, exactly. It definitely sounds familiar to me. We're like, I knew that system was rickety, and now we have, I'm sad that we had the outage, but now we have the prioritization, and now we have the justification, and maybe the permission, if you like, to prioritize fixing that thing we knew was broken. The other thing that's really important is around cross-functional collaboration. So in my experience, the best decisions, and I'm talking in this example about the prioritization decisions about what things are we going to tackle first going forward, those best decisions are made through a partnership. So not just by engineering, but also by product and business and other stakeholders. And the way that one of the things that I maybe stumbled upon in this pattern is that by doing that collaborative prioritization, we end up having shared context. So what we end up discussing, engineers are sharing and product and business people are hearing, for the most part, sharing what the trade-offs and what the implications are of decisions we might currently be making or decisions that we made in the past. And what I have found is most of the time when people disagree, it's not because they actually disagree on what to do, it's that they don't tend to be sharing common context. Does it make sense? Like a lot of times, not always, but more often than not, if people are sharing common context, if you share what you know as an engineer and maybe the business person is sharing what they know about the business implications, then we can collectively make the right decisions. And when we don't make the right decision, when we don't agree, that's fine too, but we also need to have a culture around disagree and commit. So this is something that Intel and high output management, Andy Grove, way back in the 70s, the idea that we're gonna have our say, we're gonna transparently discuss all the issues, and if we disagree, great, we're gonna do whatever the consensus is, but we all commit to making the consensus decision work together. The last thing I want to say in this section is this wonderful quote from Winston Churchill, which is, "Never let a good crisis go to waste." So again, like I mentioned, in all three of these instances, they have catalyzed big changes in how the engineering organizations operate and how we think about prioritizing and funding reliability improvements. And I think that I think that if we had an outage and we did nothing about it, that would be a waste. Does it make sense? This is not manipulative. This is like, look, we had a customer impacting thing, and we owe it to the customers to do better by them the next time. Cool. So the next set of lessons is around quality and discipline. And the main lesson that I want to leave us with here is that quality and reliability are not just engineering concerns. Quality and reliability are business concerns. So I get very uncomfortable when there is a discussion that's like, oh, that technical debt reduction, or that improvement in reliability, or that improvement in performance, oh, that's engineering stuff. No, dude, that's business stuff, right? That's stuff that directly impacts the customer experience. And I have found that we need to get to the, again, with sharing of context and collaboration, we need to get to the point where we're all sharing the feeling that quality and reliability of the software that we produce is actually a business and a customer concern. Who's ever heard this? We don't have time to do it right. Okay, laughter and hands raised. Here is what you might say in response. Do we have time to do it twice? Because that is often the trade-off. For a mature company, often we want to make sure that we are, when we produce something, that we produce it solidly. I don't mean perfectly, but I mean solidly so that we can leave it and go on to the next thing. And what I have found, a little bit counterintuitively, is that the more constrained we are in time and resources, almost the more important it is to build it right the first time. Why? Because we don't have time to come around and do it the second time. Does it make sense? Cool. In this vein, I like this quote from Steve Jobs. He's thinking about it from a product perspective, but I think from an engineering perspective also. Don't try to do everything, just do one thing well. And I think our users would thank us if instead of producing 20 features that were maybe half done, we produced 10 features that were really solidly done. Cool. And in service of that, one of the things that, it's very obvious, but one of the things that I've instituted with my teams is having the team come up with a definition of done. This is one of the examples from one of my current teams. You might have additional elements that you'd add yourself, but something should obviously be feature complete. There should be automated tests. We should release it to production. We should turn any feature gate or feature flag on. It needs to be monitored well, et cetera. One of the things that I have found that has contributed to issues that we see is this distinction, this idea of a vicious cycle of technical debt. So those of us who have raised their hand and said, we've heard no time to do it right. So what the implication is, then we do something quick and dirty. We accrue some technical debt. That means that we, next time, have even less time to do it right. We do something quick and dirty, and we go round and round in this vicious cycle. And it's our job, and sometimes a crisis can be a catalyst for this change in behavior. We want to change this around from a vicious cycle to a virtuous cycle. So a virtuous cycle is something where we make an investment in quality or reliability. We have a more solid foundation that gives us the confidence to move faster, and then we are able to free ourselves up and make more quality investments. And that cycle moves in the positive direction rather than in the negative direction. So the last set of lessons I wanted to talk about is about how to drive this change. I still consider myself an engineer, but let's be honest, I'm a pointy-haired boss. So I'm going to talk to you from the perspective of what is it like as an engineering leader trying to motivate teams to improve this stuff, but also equally how to communicate with my business partners and product stakeholders about how to drive this kind of change. And so the first lesson that I've learned over time is that no change happens if it is not both top-down and bottom-up. What do I mean by that? I mean that we need to have people that are on the ground from a bottom-up perspective motivated about improving quality or improving reliability in this particular example. They need to be motivated for their own reasons to want to do something in a new way. But also, we need to have a top-down set of goals or a top-down set of permissions, if nothing else, to allow and to encourage that bottom-up grassroots stuff to happen. Does it make sense what I'm saying? Probably all of us have had the experience where they've had the top down without the bottom up. And that is like every enterprisey, do this because we said so, and like nobody believes it and it never happens and it's not a successful thing, right? People have had that experience. But so that's top down without bottom up. But the bottom up without the top down is also equally sort of disempowering and equally unpleasant. And that's all of us at the grassroots are desperately trying to, I don't know, improve the quality or make these reliability improvements or move to a new architecture or something like that. But we're not getting time, permission, motivation, even recognition from leadership. Does it make sense what I'm saying? So like what I have found is every change, whether it's an architectural one or a behavior change in the product development, all has to be both top down and bottom up. So the other thing that I would mention is there are a couple of ways of, if you have a large-scale sort of improvement or re-architecture program, as I mentioned here, there are a couple of ways of kind of funding it, of folding it into the product development process. So one obvious way is to just fold it into all the projects. So like, let's imagine everything that we do, we also try to improve reliability at the same time. That's a great thing to do if we can make it work. The thing that works best, though, when the quality or reliability improvements are scoped to a particular team, right? When they're scoped to a particular team, you can easily, transparently, but you can pretty straightforwardly fold it into that team's work. But often these kinds of broader reliability issues, and certainly, again, architectural changes, can only be done, in my opinion, across teams. Like almost by definition, these are cross-cutting concerns across a bunch of teams. And what I have found is the best way to do this is have an explicit discussion as an engineering leader with the business and product leaders about, hey, we don't want to have any more of these outages. We'd like to improve reliability. Here's what we need to do. We need to make a concerted investment, and you and I can figure out together, we can all figure out what the level is. I don't know, 20%, 25%, 30%, whatever. But we agree up front together on this is the amount of investment that we as an overall organization should make in terms of, again, improving quality and reliability. And I have found that worked at eBay, that worked at Google, that worked at Stitch Fix. I'm doing a similar thing at WeWork. So this having a conversation up front with the business and product stakeholders around a global investment, that's really helped, because it gives it has the nice benefit of you're being very transparent about the level of investment you think that it needs, but it also means that it relieves the business and product people from the responsibility of like checking every single one. Does it make sense what I'm saying? Like oftentimes, like it's actually legitimately my job to say, given a 25% investment, here is how my teams are going to improve all this stuff. That's actually literally my job. What isn't the business and product people's job is to like maybe nickel and dime those things. Like I'm very transparent about what we're doing, but it's not a productive use of everybody's time to talk about each individual line item typically. There's too much missing context back to our earlier discussion. Okay. The last thing I would say in this is that you have a surprising ally you probably don't think about in this. Your unexpected ally is actually the finance team. Why? The finance team they are trained in managing risk, right? So most people who are in finance are good at managing low probability, high impact events, right? That's what hedging is all about. And so I have found in multiple organizations that my best ally in terms of like improving the reliability and the stability of the system is actually the finance people. And together we can often make an effective, I'll say, business case for this kind of stuff. So we talked about these three kinds of lessons. We talked about leadership and collaboration, we talked about quality and discipline, and we talked about how effectively to drive change. If you don't work in an organization that feels like you could do this very comfortably, first I think you should try to change your organization, work at whatever level of leadership that you are. But if you've tried that and you that hasn't been productive, then I have this wonderful quote for you from Martin Fowler, which is, if you can't change your organization, you can change your organization. Completely unrelated to, thank you. Completely unrelated to that, by the way, we're hiring at WeWork. We actually have 700 software engineers. We're based here in New York, but we have lots of other places, including Tel Aviv, San Francisco, Seattle, Shanghai, and Singapore. Thank you very much for your attention. I'll be around for the rest of the conference for questions.